Yeah, I can't hear you either, Sergey. Hey folks, let's get started. Okay, so first on the agenda, we have Swati with the device manager recovery bug fix backwards.
Yeah. Yeah. So last week we had this device manager bug that was fixed, and I have the link kind of added in the agenda doc. And the aim was to ensure that the recovery flow is correct. And what we've added as part of that is extra checks to make sure that the application pod requesting a device is admitted only if the device plugin has registered itself to kubelet and the underlying devices are healthy. Given that the device manager is a GA feature, I went ahead and created a bunch of backports. The core changes are very straightforward, but we had to add a bunch of end-to-end tests to ensure that the feature was well tested. The cherry pick deadline is end of this week, and Sergey suggested in one of the review comments that it's best that I have a discussion with the community members and gather feedback. So I really appreciate everyone's feedback. If there is any concerns in backporting this fix, or if everyone's okay with that, please let me know. Yeah, there you go.
Can everyone hear me too?
Yeah.
Yeah, we can.
So yeah, strategy. What you summarize what happened, which it is match the old bug what we addressed long time back in the open source. So that's why earlier I thought it's OpenShift when the bug first report. I thought it's OpenShift integration
Yes.
issue. Instead, think about it is open source issue. So, but I did. This morning after I saw you ask a chair pick, so I did ask the GK internal because I saw that in the regression, because I saw that it's like there's some new change earlier last year and caused this regression. So that's why I want to wonder it is so it is because a little bit concern for me it is the cherry pick to the existing GA the release, right? So I want to just give me a little bit time, and once I got the report back from the internal production. Basically, it's just because internal production is just using open source Kubernetes, right? So I want to understand why I never heard this production report. So then I can process this whole thing. Yeah.
Absolutely. No problem at all. Just
my perspective. Yeah. Thanks for the report and fix the issue.
No problem. Just one more thing I'd like to point out. I think the reason that it's affecting us is primarily in single node deployments. I think typically if you have multi-node deployments, you can drain the nodes, but the use case that we care about, it is specific to single node Kubernetes OpenShift deployments, and that's where we don't have the ability to drain the node, and that's where it's affecting us the most. And I remember as well, David mentioned that in case of GPU plugins, he noticed something like that. But if you can take a look and give me a green signal or whatever your feedback, if it's okay to proceed or not.
Yeah.
And Swati, just maybe a quick question. Can you give a little more details of how the bug is triggered? Is there anything specific that needs to happen? Is it just any kubelet restart, or it's like a race condition, or
yeah, so
how can it be triggered?
Yeah, so in the scenario that was reported to us, it was that the underlying device wasn't provisioned properly. But in the end-to-end test case that we've provided as part of the PR itself, what we do is we intentionally prevent the device plugin from registering itself to kubelet. And because of that, the underlying devices are essentially not healthy. And we should see the application pod that is requesting the device, it should fail at admission time. And this is, of course, after like the node has been rebooted and kubelet has been restarted. You would notice this, so, steady state, all your application container device plugin, everything is up and running. You reboot the node and the registration does not occur, the application pod should fail. Application pod, which is requesting device. Does that make sense? Should I probably do a better job explaining it?
Yeah, no, that totally makes sense. But just to be clear, it's the device needs to be unhealthy after reboot. Is that accurate, or it's?
Yes. So when it's steady state, everything is up and running, everything is allocated. And when the node is rebooted, there could be a scenario where your underlying devices haven't been provisioned. It could be because, say with SRV Nix, you need to ensure that the device driver is up and running, or for whatever reason, the device plugin pod appears after your application pod, because essentially at recovery time or node reboot time, you have no control over the ordering of pods. It could essentially happen. And here we were attempting to make sure that, in scenario that it happens, we are taking appropriate actions to prevent the pod from incorrectly going into running state.
Gotcha. Makes sense. Thank you for the explanation.
Thanks also for pointing out the single node, because in the summary, and I didn't realize that's the single node. So we definitely didn't fix the single node issue in the past. So this is why when you describe that kind of things, I said we try to make sure the device plug-in is not announce the capacity, right? So until everything's ready. But for the single node, that case is, I think we didn't, not just single node, actually, single node and also node reboot, and just simply read from the checkpoint and claim they have the capacity, because we did try to like after node died or reboot, we try to re-register, recreate after that node or re-register node. So there's some prevent, but the single node case we never, I don't think we handled. So thanks for bringing that up. So, okay, I will approve that one just after this meeting.
Perfect. Thanks, John.
Great. Thank you, Swati. So next on the agenda, we have Karthik with dynamic node resize proposal.
Yeah. Okay. Hi, everyone. So recently, we submitted an enhancement proposal named node resize. Basically, we are trying to solve a problem wherein which we want to dynamically change the node compute capacity without restarting a kubelet. So the current workaround is that if you increase or decrease the node capacity, we need to restart a kubelet. So we want to avoid that, making it completely dynamic. And so the use case we are trying to solve is that in a situation where adding a new node to a cluster is considerably taking more time rather than updating existing machines. And also if a user cluster want to manage with a limited number of nodes. So these are the couple of use cases we are trying to handle with this proposal. And so we have done some observation and we created a Google Doc and shared across the SIG Node mailing channel, and we got some feedback as well. So I would like to hear more from the community and guidance to take this forward.
I had a quick question. For the discussion doc that you sent, you enumerated some things as non-goals, and I'm curious if you could explain the motivations on them not being goals. Like, is there something unique about your environment where you're not using devices, or you're not looking to hot swap devices, or is your workload not needing any isolation around or affinity around CPUs and memory? I'm just kind of curious why those two items were called out as non-goals.
Yeah, so initially when we started with that, our goal was only regarding the dynamic resize, and we consider them as non-goal. But later with the discussion, the feedback, it is known that we have to make them as a goal, and we have to improvise the resource manager initialization or the reinitialization depending on the changes. So as it would affect those components as well. So recently we have moved them to the goals in the enhancement as well.
Okay, and then just to follow up then, is your goal to be able to increase any resource as well as decrease any resource, or what, given the removal of those from the non-goals, is there any constraint around resizing you're wanting to do?
Yeah, basically we are looking to both increase and decrease the resources of a node.
With no restrictions, correct?
Yeah.
Meaning, so like included in that would be the ability to decrease the amount of resource on a node for its currently scheduled pods?
Yeah.
Okay.
Yeah, I think pod readmission is one of the big topics. Can you hear me, by the way? I reconnected.
Yeah,
Okay.
we can hear you.
Thank you. Yeah, pod readmission is a big problem for this PR, this cap, and maybe some other caps. Like one thing we discussed, like I commented somewhere here, in AppArmor case, for instance, we have the case when AppArmor was disabled, and then even kubelet restarted. Like, what do you do with pods that needs AppArmor? That was another kind of readmission situation that needs to be covered.
Okay.
But besides readmission, I also like this cap is targeted on like automatic resize, like whatever CAdvisor tells you, you do. So first comment I put in document about throttling of this situation. So if CAdvisor is like flaky, or like you have resources quite dynamic, I don't know, for some reason, maybe some like ballooning happening or some like missed error in CAdvisor, then we should at least threshold how we change node size. But ideally, I think we may also have approval-based resize. So CAdvisor can detect the new size, but then you may need to go through some API call to actually do resize when it's possible. I think it will be better for some cases, especially when cases when there is like some virtual environment that actually bigger size, but like somebody wants to control it and from a site and make it smaller and bigger based on demand, and maybe they have information about hardware, virtual hardware that doesn't like CAdvisor doesn't know.
Well, there are a couple of other cornerstones, corner cases in all of this. CAdvisor, if I remember correctly, how it represents the topology information about a machine, it will not showcase a proper scenario when like one of the threads of a core got offline, or when the, like, let's say like CXL memory and like the new memory region will appear on the node dynamically attached, or even worse, like when something disappears. So like when we are talking about VMs where we can do memory ballooning, it's easier, but like starting jungling when you have like cores with different amount of threads, it will be, well, kind of worms we are opening, I would say, with current implementation of set of managers we have.
Okay.
I mean, I'm not against, don't get me wrong. I'm not against. It's just what, like, there are a lot of underwater stones where it might showcase a bunch of problems.
Maybe one other thing that would help me could be my information was out of date, or I just have forgotten this. If the feedback loop was on whatever CAdvisor has observed, then obviously the channel to increase or decrease resources to the node are happening out of band. Is there anything you could point to in your KEP that might describe the state of the art, whether that's on Linux or Windows hosts, with respect to what resources can be dynamically added or removed without a reboot? I think that would be helpful in just even understanding the scope of restrictions. I don't have that to memory, and so maybe Dawn, you have your hand raised. Maybe you do. I don't know. I'm sorry if I jumped the hook. Thank you.
I think everyone raised a lot of complexity here. I totally agree. So that's why I can lower my hands here. But I do want to say, bring some memory to some folks here. Um, I do have concern this one. Maybe I'm more concerned on this one. Could be a lot of non-go being there, but the complexity is embedded in those non-go without those kind of the resource management, without those part the admission. I don't think this can fly, can be beneficial to many users. I also worry about the people. Even we make this work, I think this has been a couple of years ago, some like the similar proposal sent to Kubernetes. I think we worked as together and reject that one because that's really could the potential harm of Kubernetes. So similar proposal is kind of the dynamic node or maybe virtual node or virtual Kubernetes. It's quite similar. So the node size can unlimited expand it. So I worry about once we start to this one, then we goes to that direction. I'm okay to build something on top of the Kubernetes, outside the Kubernetes, and to hide those details implementation to treat the entire cluster as like a virtual giant pool and the resource. But really on the Kubernetes layer, I think that's the complexity. You heard many people mention that different complexity, right? So I don't want to repeat there. Many resources and how you're going to manage dynamic. But on the Kubernetes, the common layer, what we are doing is purely from the Kubernetes open source perspective. And so I really worry about we couldn't handle very well and abusively using and even harm of the Kubernetes health in general. So that's just my comment here. So I want to say that I personally don't want we continue on this thought unless people give me more opinion use cases here. But I also want to discuss those cases. Can we handle on top of the Kubernetes? And so that's kind of this is my opinion. I'm pretty straightforward here. Sorry about the disappointed comment.
Yeah. Okay.
Clayton has a hand up.
Yeah, I had two questions. One touches on what Dawn brought up, which is there an alternative that deals with a less invasive way of fixing it in the kubelet by pushing it to someone managing the node who wanted to do this more aggressively, like replacing a node with another node. And it's possible to orchestrate some of that today. It wouldn't be easy, but like some of the things that we might have to go spec out to do that might be a little bit more manageable. And you can imagine that as like, it's up to you to stop the kubelet, do API operations, and then start the kubelet. And if there's bugs in stopping and starting the kubelet, and the kubelet needs to handle things like devices go away when a node is rebooted anyway. So some of those efforts, like if an implementation path like that might actually help in other ways and be simpler to implement because it could be done on top and improve through testing basic changes. So that's one thing to consider. I'll make that comment in the proposal. And the second one was a concern about the dynamic resizing would be, a lot of the third-party plugins, device manager, CPU, already are a little fuzzy, have bugs around dynamism. Is the expectation with the KEP that each of those components would be changed to support dynamism the same way? Or is it left as, we're just going to focus on these resources and then carry it out to the others?
Yeah, so we want to change those plugins to accompany these changes as well with the dynamic resize. That's the goal.
I mean, I'm generally in favor of improving how we deal with dynamism in the kubelet, because we're not to say that I don't agree with Dawn's concerns, just there's a lot of dynamism in the kubelet that's just broken today, and it's all subtle stuff. Anything that helps, anything that forces us to go in and test it and be better, I think is a net positive for the kubelet.
Sasha.
Yeah, so I just wanted to answer Don's comment about the use cases. So, like, the main use case, beside the virtual machines, is what there are some changes in the hardware what is going to the market or already on the market. So, multiple hardware vendors implemented the feature called CXL memory. And one of the properties of this thing is possibility to dynamically attach or detach that memory. So the scenario when you have a node which is under memory pressure, you can like issue like to the management infrastructure, like please attach me like another 10 gig of memory, and from top of the rack pool of memory, it will be dynamically increased. And when the same, we're decreasing. So it's something what will be common in probably like next couple of years, but to make sure this feature is available, we need to start to work on it now. Or another thing, like another example, like Swati or Francesca might also say something like there are a bunch of telco customers who can say, I want to run my workload on the full core exclusively. And for them, shutting down the hyper-thread of a core is quite, I wouldn't say like common situation, but desired situation.
I saw there are some other hands. Clayton, is the stale hands, or you still raise your hands? Otherwise, I want
Stale
to.
hand.
Cool. So maybe I should rephrase what I asked for. So my most concern it is abusive to using this feature. Right? So I mentioned that a couple of years ago, there's even that may be still going on. I don't know how that one I didn't follow. The dynamic Kubernetes of virtual Kubernetes on top of those things, and it's unlimited, and it's never, there's the boundary. But Alexandra, your use case is actually different here, right? So your use case is the dynamic attached memory, and there's the even like the couple years ago, we have the GCE also have the case like resizing node. And so the problem it is we have a range, right? So you could upfront for those cases, actually you have the range, how much you can dynamic is unlimited resource, you still, right? So you could, we could handle from there. So like, okay, when I report a node, you basically know what's your maximum size. This is what I told the GKE team back then, but they never come back to me, unfortunately. But that's what I told them. So you do know what's your really maximum of the size. You know what's your latency to grow from the minimum current what I available resource to grow to the maximum. And then you give me that information, then we can handle. Still, it is more manageable. It is predictable. So that we can give that signal to the scheduler and give that signal to the resource management, even on the node. We can handle better. I did share this to the internal GCE team, and but they never come back to me. So I share here, since we have more use cases, really common use cases, we can start from there to discussing. So, but I really concerned about we go down to like unlimited resource. So everything's in hide, and you basically treat the Kubernetes as the scheduler. And I don't think about we can take that big jobs. We want to handle, we could handle at the node level, work with our kernel, handle those scheduling job much better to manage off the resource or latency throughput. Even throughput we cannot handle well. So we only can do that part of the job, right? So that's kind of my concern to abusive go crazy. So this is why I try to rephrase. If we have the real vendor, device vendor have the real potential in the future, we could start to talk about those kind of things. But I want to start from like how Kubernetes can manage how admin can manage those kind of things. And on top of those kind of surveillance, or even go crazy, like the nodeness of things, I think that's can build on top of us, not in open source Kubernetes node team here.
Well, just one comment about the provisioning potential capacity. The problem is what the kubelet trusts what CAdvisor tell, and CAdvisor doesn't know anything about the potential capacity. It just says like, I see it how it is right now, and this is my node capacity. So for admin, there is no way to tell what, like, I have some additional potential capacity. And actually this cap is actually to re-trigger the like CAdvisor to reread that information. As I said, like I know what it will be a lot of corner cases in it, but in long term, it's something what we probably need to look at anyway. It's more like technical problems rather than like, should we do it or not? Just my opinion.
Right. Maybe I think we can move on to the next topic.
Yeah,
And,
thank you all for the feedback. Yeah.
Great. Thanks. Next is Clayton with kubelet state improvements for 128.
Sure. So the previous two topics deal with some of the things I tried to summarize in the attached spreadsheet. I hope folks have seen that. I sent that around a while back. But if it's your first time seeing it, there's a number of intersecting challenges in the kubelet about how the kubelet, takes input, and then, different subcomponents, how they react to that input. Admission obviously takes desired pods and turns them into pods that the kubelet is actually desired to run. There's a couple of bugs on static pods that have some short-term implications. But a number of the things that we talked about even today, like admission and resizing, as well as in 127, the in-place resizing of pods, made it obvious that we have some challenges in describing and reasoning about what is the correct way to add some of these features. And as we get more of these dynamic features, it figures it's a good time. So for 128, I was going to focus, David Porter's been working on this along with me. I was going to work on trying to get some of the clarity in the kubelet around the difference between what someone has asked the kubelet to run and what the kubelet is actually running. And that's kind of been some stuff that's been working on for a couple releases. That'll help the static pod stuff that Ryan had asked about. And then working with in-place resizing to improve kubelet admission to be a little bit less, the current approach is a start, but it doesn't really sit cleanly with a bunch of the other components, and it wouldn't be something we could extend to new components. I was also going to take a look at that. For folks who have seen the charts, are there any other key issues around admission and state management in the kubelet, any of the issues that you might have seen in that deck that are important that either folks would like to work on with David and I, or need additional capabilities in admission, for instance, that might justify coming up with a bigger design than just the KEP themselves? So it's kind of a general question to anyone who has changes coming in 128 or potentially in 129 that would be big enough that they're not quite sure how they would accomplish it in the kubelet, and it involves things that you want and dynamic changes over time, as well as admission. If it says any of those three magic words, I would like to know.
I don't think it's dynamic enough, but kubelet resource management plugin may affect pod admission, and it will be pluggable, so it's not static enough. But I think Yeah. I don't remember the last state of this cap to understand how, if it will be affecting your work at all.
Certainly, I would probably say anything around dynamic resizing of nodes would need to be fairly, like, we would want to make sure that we get the design of anything like that in the cap. Are there any things that folks are working on, like in CPU manager, device manager, plugins beyond what you mentioned, Sergey? Anybody know of anything that's going to be going in that has some dynamism?
Yeah. We can share with you our planning. The problem is, even we have the planning, a lot of time is not that predictable, right? Depend on the author's bandwidth, depend on the reviewer's bandwidth, approver, all those kind of dependencies. So, but we can definitely share with you our current planning, like what it is people commit to say they are going to working on. There's the several. Oh yeah, Manu already shared with you. Manu, you're fast. So you can see that there are a bunch of the people and to working on. Yeah, look at the 1.28. There are many things people say they might want to work on, but did not clearly say we definitely will deliver or lock down the resource.
Yeah, the one that, and I think if I had realized this earlier, David and I have been working on like some better descriptions of this. If I had realized that in-place resizing was going for 1.27, we probably could have helped some of the review. And so some of what I'm looking to do is I'd like to improve the review process for complicated state changes to the kubelet by having better docs, better explanations, and better code structure. Because a lot of this, how kubelet deals with state is go ask someone who hasn't worked on the project in 5 years, or somebody who's very busy. And I think that's the thing I'd like us to get out of by the end of 1.29 is you can go read a doc and understand what the kubelet is doing when you want to change how data flows around the kubelet.
That's the wonderful. Okay. Thanks.
If anybody else has anything, if anybody has anything else, just reach out to me.
Clayton, if you can look into the sidecars enhancement and changes, that'd be awesome too.
Okay. All right. Yeah.
One of the things I was looking into that would be nice to tackle is the issues around termination grace period, like with pre-stop hook, blocking pre-stop hooks, basically like are not factored into termination grace period. I think that's something nice can also help with that effort to fix in the cycle.
That actually reminds me of one more. One of the things that David and I have noticed is there's a lot of subtleties of the kubelet's behavior that aren't well captured by E2E tests that stress them. One of the, along the lines of the termination thing, the context cancellation in the kubelet, when a delete request comes in or the pod exits, something that can come in and say like, hey, we've stopped this and we're moving to the next phase. One of the things that was pretty clear there is it's really hard to explain how to test this. And so some of the contributions from folks needs a lot of handholding just to get better tests in place. So if there's other people who are looking to build better testing as part of their caps or their use cases, I think this is also a fruitful angle for us to look at how we can catch more issues with fewer tests and catch some of the restart issues instead of going and catching them one by one as each new component is added, putting that on the KEP author to run more aggressive testing around new features that'll catch things like kubelet restart or early termination, stuff like that. So if any of those things interest you, come find David and Ryan.
Yeah, I wanted to know that we did a few improvements in testing for sidecars specifically. It's mostly about life cycle, less about restarts. But yeah, if you're interested, look at this cap that you mentioned here. I think it's a good transition to next topic from Zach. Another dynamism or change of behavior proposal. Zach, do you want to speak out?
Sure. Thanks. Hey, I'm Zach. I have never presented here before, but I know many of y'all. I have been trying to bug Sergey and David for some improvements in crash loop backoff behavior, and they suggested I come here and present like why I care about crash loop backoff and what options we have with the possibility of working towards a cap, perhaps for 128 or later. So there's a doc linked in the agenda that I tried to summarize the issues, but crash loop backoff, for those of you not familiar, has basically sat since the beginning of time in Kubernetes with a static policy of container crashes, we we restart it after 10 seconds. Next crash, we back it off by doubling and keep going until we reach a back off of 10 minutes or max 5 minutes, sorry. This actually presents a challenge, and I'm now in a role with the GKA games team, which was mostly responsible for Agones, which is the thing that hosts live game servers. But previously, I was in a role maintaining GKE Kubernetes control planes, which were heavy static pod users. Actually, in both of those roles, I had issues with crash loop backoff, and I'll explain why. In the previous role, and this isn't unique to static pods at all, but anytime you have a cold start with a lot of with a long chain of dependencies, so you have C depends on B, depends on A. If that cold start is a little slow, so A takes a little while to start out, all of a sudden B gets backed off more and more, and then that can easily cascade to C getting backed off more and more. So especially in Kubernetes control plane, you had etcd. Eventually, we might have. I think we actually introduced a dependency on etcd that something etcd also depended on, yada yada, and then kubeAPI server depends on that. We actually saw reliability issues where our SLOs were getting impacted because kubeAPI server wasn't coming up in the kind of rare case because these initialization chains took a little too long. In a different side of the coin, Agones has an interesting case where in order to not exacerbate or in order to not put undue load on the Kubernetes control plane, we would like to be able to restart the container within the pod rapidly. So in the Agones case, each of these little live game servers is effectively a shared simulation between players. So you're logging in, you're have some Street Fighter match, right? And you're both connecting to this thing, and then it recycles the entire pod or potentially the container, depending on how they have it set up. Right now, we have a kind of hacky workaround in Agones where you can restart within the process. So we allow that kind of within the life cycle in Agones. But there's a lot of people that don't want to restart within the process because they're basically saying hey, we run a containerized workflow anyways. Why am I restarting in the process when I could just bounce the container? But the problem with bouncing the container is it only works for workflows where, it only works for games whose session length is whatever it is, 10 minutes, the back off reset timer. So again, coming back to say Street Fighter or something, if you're playing a 2-minute match against someone, that container is going to stop at that 2-minute mark and have no opportunity to be recycled without backoff. So that's kind of the impetus. The doc talks about it a little more. I kind of wanted to explore different options for that. I think the easiest and kind of different options for changing this. On the complicated end, I feel like we could introduce just API that is straight up for this pod, I want this exact backoff behavior. I think that might take a little bit of like kind of tuning to understand what the right bounds are. Like, you know, what's the minimum that kubelet could support for a backup speed or anything like that. A super simple approach might actually be riffing off some of the work done in like the recent jobs kept. Might even be something like just having 2 static policies, one of which is, or maybe one tunable policy or something of that nature. Have one policy that's for containers that exited cleanly, and another like strictly looking at just exit codes. And maybe another policy for containers that, you know, crashed or had some other infrastructure failure or something of that nature. Anyways, that's kind of roughly, I'm trying to think if I presented any other options in the doc. Yeah, so I actually wanted to explore that a bit here. See if y'all had ideas, had other approaches that we should be considering. Any kind of questions?
So the backup, sorry, any other people raise their hands? Okay, sorry. So I just want to say that the backup, we know backup algorithm initially is just oversimplified. That's just back then, it's just to protect the node, right? So because you worry about those, right? Zach, you were there, and we discussed, you complained this before also too. And we all know that's the problem. We want to optimize those things, enhance this one. So there's the one case is actually you are really triggering me to thinking is if the on purpose, there's the certain process like non-cascading the workflow, and when the restart, actually it's the properly restart, and maybe shouldn't be punished by the back off restart. We only really go, it is punish this to the crash loop of the container. Try not there need them to, because we didn't correct them, and we shouldn't need them to DOS attack our node, right? So if it's properly, so there's the way, yeah, you propose something like the maybe first crash, but how we are going to track this is the first time, right? So we do have some, but that restart the count not properly. I have to say that, but we could do some policy like to say, oh, certain things you maybe don't need, like first restart, first crash, maybe you, or maybe execute code is the proper restart, and we shouldn't punish by the back off crash loop things. So we could start those kind of things. I just want to share here because we know that problem from day one, oversimplify policy to move forward. Yeah.
It got us this far. So
yes, 8 years.
And I,
okay.
This is Clayton. I was in favor of this. There's a couple other use cases. The daemon job proposal also got me thinking about this, which is like basically if you want to do anything that applies policy on nodes, and the daemon job proposal, for those who aren't here, was basically a daemon set can be used to enforce policy on nodes. And actually that's how in practice a lot of people use it. You know, you want to force pull images to all the nodes. You want to go change some state. You want to deploy a network plugin. Right. A lot of those, there's a separation maybe between you apply a policy to the node and you run something on the node. But a lot of the applying policy on the node variants, the nice thing about a daemon set is you could just keep running it. And the naive way to do it would be you would run it, and then you would run it again in a little bit when it changes. And we can let people go write bash for loops all day long. There's some use cases in there though that as long as we can properly, like as Don mentioned, as long as we can properly make sure that we're not, the resources that we use in the kubelet for a container that are outside the container tracking are properly limited. I think we can dramatically improve what we do today Dawn kind of triggered another thing, which is there are things that we don't account for. Like a crash looping pod is using system resources that are sometimes poorly accounted for to the pod. It would be awesome as we go through this if we can come up with a justification for quantifying the actual impact of restarts on the node, even like at a really high level. Like, what does it actually cost to restart a container in terms of kubelet time, kubelet disk time, and what does the pod do, and then what does container runtime do? That's a good input to like maybe just an operational parameter, which is how much. Yeah, Derek's point, I was thinking about system D as well, is like there is an administrative policy, which is how much resources do you want to accept as overhead? And that's the real key reason that crash loop backoff exists, is to, with the worst policy, even moving up to another level of policy, just like how many resources per second do you want to fairly divide among workloads, and leave that up to the admin. If we can keep it below that, I think that's another option as well.
For sure. Sergey, I think you had a hand.
Yeah, I really like this angle of minimizing, like improving this behavior for all pods, like better accounting of resources and like making it cheaper to restart would definitely help everybody. And I think in this specific case, it also resonates with another cap where pod container intentionally want to, instead of saying that it's a benign failure, please restart me as fast as possible, also maybe indicate that it's very bad failure and you need to like terminate the entire pod because it's like such a bad failure that I cannot run here any longer. So I think from API perspective, there may be two features coming together. Like when container saying like either this failure specific exit code or specific type of failure is benign or it's very critical. So I think there is opportunity for API change that can be done reasonably narrow scoped.
Cool. Clayton, was that a new hand?
Sorry, I just expected modern chat video programs to take my hand down when I unmuted. Sorry.
I wasn't tracking. I just, yeah.
David.
Yeah, one of the things I think we should think about here is like when we think about this, is it up to the admin to define kind of what is a crash versus not, or is it something like we observe? So in the sense of like, I see two ways we can progress here, right? One is like, say we look at the exit code, right? If it's a zero exit code, it might be successful. Maybe we don't limit it or something like that. But there might be a different case where, you're deploying some application where you don't control the exit code, right? And you want to force it to not obey by the crash loop backup. So I think it might be useful to see what we're trying to solve, like what scenario we're trying to solve here. It's the assumption that we do have control around the actual application being run and can modify it to notify that it's a crash or not, right? Or we can't. So that might be helpful in when we design this, right? Thinking about what case we want to address.
Adding one more point to static pods should probably not be put into crash loop backoff at the rate they do today. Like this is a bigger discussion, but it gets into some of that chain of dependencies. I'll be sure to add that comment when we get to it. But thinking about it now, there's very few cases where the full backoff makes sense for a static pod, because that's the administrator's responsibility to make sure that the point of the static pod is to be running, and our full backoff is.
In that scenario, sorry, I do have a hand up, David. But I'll briefly respond to Clayton here. That scenario where, like, if we had just tuning for the like configurable parameters on the kubelet, it might work fine, especially for like KCP or the Kubernetes control plane case. But
yeah, if we dramatically improve it, it may not even be necessary. I'm just I I keep finding ways that static pods don't do what people use them for, which is run critical system components that must come back sometimes in order to make sure that the cluster comes back. And so if we pick a good default, I'll just add that as I think it'll be a goal on whatever KEP comes up is static pods. You don't have to think about static pods doing the right thing. They just do the right thing by default.
Cool. I think I'm done if there are no other questions.
So from action items, do you want to try progressing this KEP as API change, or do you want to progress as resource utilization? Zach, do you want to work on one or another? Do you have preference?
Sorry, what was the second option?
Like one is improve like the situation for everything. Just confirm that we don't waste too much resource on restarting and just remove this 5 minutes restart for everything. And another option is to have an API that will allow to toggle like how much is it benign restart or not.
I think the latter seems easier to adopt, like, although probably longer to implement, like the API change was probably longer to get in. Do you have an intuition here?
Maybe we need to get presented an API review and get a sense, and SIG apps maybe helping with that. So if
we have a question here. I hope we address this properly. We know this. I hope we address this properly instead of just simply get rid of that 5 minute right things. That's might be. I think if you want to do that, you don't need to come to the signal. That's one of my things, because you could do that very easily at the node config. We could expose that one, right? So then you could handle that node config. But that's not, which is mean that simply will apply all the container, all the pod. I'm not sure, maybe in your cases, because you are talking about this particularly special cases. In your case, that's okay, but I'm not sure for all the other cases. So I hope that's properly.
I think having it in general as just node config is too limiting, in part because I think you're going to want pods with different configurations.
Exactly. So that's why I hope we address properly and introduce a different policy. I think this is the good things to start this conversation. We all agree this part. This is not the first time we heard those complaints, but it's first time people give us more detail about use cases, right? The workflow and the process.
Right.
Let's leverage this situation and make this correct.
Okay.
Exactly. I want to echo what Don said. This was a really useful, interesting conversation. And one thing I was curious about is I did put in the chat, and I didn't speak up. Like, I was trying to think mentally, if you had total control of your Linux host, what you would have wanted the behavior to be. And like, so I just went down to like the init system we're always commonly working on here in systemd and saying, what would Zach's unit file look like? And I kind of wonder in your scenario, if you had the ability to specify a start limit burst budget for your pod, if that would have been what you would have used in your use case. Either way, if you wanted to if you weren't familiar with that field, if you wanted to Google it and come back and say, oh man, that's the missing thing I would have wanted. I'm just curious if that is the scenario that we're lacking in Cube right now.
Can you give it a 10-second overview of start limit burst?
Yeah, so basically, like if you have a systemd unit with a restart policy of always, and you are failing on startup, like systemd will try to rapidly start you as fast as possible over and over again up to that burst value. And then once that burst value has been reached, let's say it was 10, you then get put into the back off period. You get put into that interval second wait. Whereas in kubelet, we put you automatically in a back off period. And it feels like what you're wanting is maybe like an initial budget to exhaust before you get put in timeout. Yeah.
I think that's possible, but like the Agones case where it's like every couple minutes, I'd have to look at how systemd handles that, because it's possible it's maybe that plus the tunable like when the timer resets, because if the timer doesn't reset, if I crash every couple minutes, sorry. But I think these are kind of details we can flesh out. I actually
I roughly thought the timer would reset the moment you were reported as a happily running pod, or you passed the liveness or readiness check.
Yeah, that's an interesting possibility. Cool.
Well, I will say that the hot looping pod is scary, so it wouldn't fix that.
Yeah.
Because you could probably DOS the kubelet that way. Just exit success immediately.
Yeah, and I don't know if any of the cases we have would be particularly grumpy about the base like 10-second one. So I mean, on the KCP side, like I certainly didn't like the 10 seconds when it came up, but like it's better than the hot loop for sure. So I think there's some discussion there for sure.
Right. We are over time. We still have some topics. We can carry them forward to next week. Thanks for joining, folks.
And among the topics, there are some links to PRs that needs approval. If somebody have time, please go through them. Thank you.
I'll make a pass. Okay, I started today.
Thank you.
Right, bye.